Well, last week I fitted up this boot, tried to see if all the mechanics of it were going to work correctly. Next I want to put my skin inside, but I did make a change on the framework with this nut underneath this toe board. Well, like many of you, I wasn't real impressed with my notch to accommodate this nut. So I did come in just behind this nut and I put a slight taper into the rest of the curve. It ended up being about 3.5, 4 inches long, kind of blended that together. So I don't have this notch anymore. Well, on this toe board iron, there's 3 holes here that accommodated bolts. Well, each bolt accommodates about a 2.5 to 2 5/8 thick board. So it looks like that's the width of the slats that would go on down through the whole curve of this driver's footboard. So there are a number of ways that the inside lining of these driver's footboards were done. At a higher quality manufacturing facility, oftentimes these were steam bent panels, and there would be 2 panels put in to cover this whole curvature. In a lot of these old pictures, you'll see through the middle there will be a cross frame that covers the joint of these 2 steam bent panels. This coach, however, I don't think was done that way. This is the one remaining board that was up underneath the toe board on the framework that was the remnants of what was left. This board measures about 2.5 to 2 5/8 of an inch. So with the hole spacings, that's what I'm guessing this was probably done where it was manufactured, probably in a hometown shop back there in Washington. If I mark out the spacings at 2 5/8, I can fit the curvature with minimal little short spaces in this curve. I'll show you what I mean here in a minute. So with the evidence of this board that's remaining, that's the avenue I'm going to take for this driver's footboard. I'm going to put a series of slats across to accommodate this curve, and I'll show you what I kind of have in mind. So I have a curved pattern here that I use for sawing out fellow sections when I'm making wheels. You can see this is a 53-inch outside diameter for a 53-inch wheel. Well, that fits fairly well on the inside diameter of this driver's footboard framework. So I've taken and marked off these little marks here at 2 5/8 that correlate with the holes in this ironwork. And I've continued that on down through the rest of this curve at 2 5/8 and calculated how many slats would work and if they will actually fill out the full length of this curve. Well, as I come down to the hinge portion of this, it actually works fairly close. Within an 1/8 or so, I may have to do some final adjustment, but these are all 2 5/8 slats until we come down to this one. This one might be a 2.5. These are the placement of the holes in this hinge. So there's going to be 1 bolt hole for every slat. So if I run my calculations out for a 53-inch diameter wheel times pi, 3.14, we end up with 166.42 inches in circumference. Well, if I divide this by 2 5/8, it's going to be 2.625. You see that I'm going to have just over 63 slats for this entire circumference. So if I take this 63.39, if I even rounded it up to 63.4, if I took 360 degrees and divided that by 63.4, you can see that our angle at each slat is going to be just over 5.5 degrees, 5.67, 5.7. If I divide that in half, each of the angles between each slat has to be 2.8 degrees. So I need to cut these slats at just shy of 3 degrees on each edge. Well, this angle for the top slat is going to be different than this just shy of 3. So if I try to calculate that, I'm going to be in this area somewhere for this top angle of the top slat. And that's going to be right at about 20 degrees. And because I did change the angle here, this first angle is not going to be at the 2.8 shy of 3. I'm going to make this first slat with a 20 degree on one side and 2 degrees on the second side. And then the slats on down will all have this just under 3 degree angle on each of the edges. Then when I get down to this final slat, again, this is going to be at the 2.5 shy of 3 degree angle, but this angle is going to be different again, and this is just a kind of a guesswork. Try to get this kind of parallel here. But that's going to be just a strong 20, possibly a 22 degree angle on this final slat. So this method of using slats to form this front curve is not my preferred method, but I think it is probably as close to the method that I think they used to build this coach. You have watched me steam bend panels before for Stagecoaches, so I have that ability to steam bend 2 panels to put in here. My next favorite approach is inspired by the building of Portland cutters. Portland cutters have curved side panels and a curved back, but as I've worked on these, almost invariably they are 3 layers of veneer that are 1/8 inch thick, laminated together to create, in essence, a curved piece of plywood. Very common in the construction of Portland cutters. Well, I have taken that same approach to cover the inside curve of these driver's boots for coaches before. There is a material that is bending ply. It is poplar, 1/8 inch thick. It is bendable, and I have taken that on different occasions and laminated together 3 1/8 inch pieces to end up with 3/8 of an inch thick curved panel that works really well for the front of these driver's boots. It's often thought, well, maybe that wasn't proper, but the use of veneers and the evidence of Portland cutters, it was very much used back in that time. So those are the 2 approaches I would use if I was going to build this for myself, but I don't think that's what was used on this coach at that time. So I'm going to use the slats and form a curve in here, but not yet glue them to the forms yet. I'm going to use the forms to glue these together, do some final shaping on the outside curve so that they fit these forms a little better, and then do my final install after. So I have the spacings of these irons off the toe board because of this toe board is already installed. And to ensure that my spacing of my hinges stay correct and they don't slide on this hinge rod, I'm going to take a thin slat and put underneath my clamps so that my spacing stay constant as I begin this lamination process from the toe board down to the hinges. So I've done some preliminary samplings, and I've cut these 2 5/8 slats in short sections with the just shy of 3 degrees on both sides, just to see if my calculations are correct. So my joints are really close, at this just shy of 3 degrees. Actually comes up at 2 3/4 of a degree. Another reason why I think these were not initially steam bent, because if they were, they would only be 3/8 of an inch thick, but the one original that I had left was 5/8 of an inch, just like I've planed these two. So if I put these on just like they are, with this being curved and these slats being straight, you can see I'm going to have this little bit of space underneath each slat, which perhaps that's what they did, but it's not what I like. So if I can glue these together at these joints, but yet not glue them to the frame, hopefully I can take these off after they're glued together, and with my rasp I can take and put this into a continuous round curve to where they fit this framework a little better. So I'm not going to worry about the inside having this little flat steps. I want to take the curve of each joint off just a little bit, so from the outside it'll have a continual curve. The inside is still going to have this little stepped design to them, which will all be covered up when there's a side panel on this boot. Now it's my speculation that they didn't go to this degree of detail when they built this. I think they probably just put slats in, bolted them together, good to go. This is where I'm kind of, in my estimation, I'm going beyond what they did. But that's just me. I like the idea of the outside curve fitting my framework better than just putting slats in. So above and beyond the Call of Duty in this case. I cut my first edge at 20. Then I'm going to come back down to about 2. So if I just let it bottom out against the nuts, I've got probably a 1/2 inch of space, maybe a little bit more. But if I were to notch it out for those nuts, I can bring it up to this 1/4 of an inch, which is just the thickness of these irons. I'm not going to get this to where it would close, and I don't think that's how the initial one was, but this is what I'm going to shoot for. So I'm going to try to mark these out, just where these nuts are going to be. I really don't think this kind of detail was used on the first one. If this was exposed at all, this tip would probably have a tendency to break off. In time it might. I had debated on whether I should just open that up, but we'll try it like this. This is what I'm going to end up with. My nuts recessed down into this top board. This is more what it'll look like from the outside. My notches aren't going to show because of my frames, but I'll have this 1/4 inch or so space between my inside panel and my top toe board. This one remaining board that was left where the bolts were, you can see it's flush. It wasn't recessed at all. So what I'm doing is kind of over and above what was done originally. In order to keep this board in position so I have something in a solid spot to clamp my other boards up against, and I'm going to glue all these joints, I think I'm going to run bolts through this just to temporarily hold this. I'll remove that all down the road, I think. So I stuck some packaging tape on the inside curve of these frames, and I'm going to try to glue these edges as they joint right here. And this tape is to keep it from hopefully adhering to this framework. So I'm just going to go one by one, and I'll have to glue it. I'm going to clamp it with some pipe clamps, C-clamps, try to get it in position. And I'll probably have to let it set for an hour and go on to the next one. So it's going to be kind of a long process. I'm just going to let that set for a while. Well, I have 3 more slats that I need to get glued in, but I'm running out of room as I'm attached to the body, so I'm going to have to detach this, and I'm going to try to put it on some sawhorses where I can finish these last 3 slats. Now that I got her all glued up, I'm going to take it off and try to float this out. Mark these so they go back in the same spot. Well, it actually turned out pretty decent. I just got to stick her back together again. Kind of relaxed a little bit, but that'll pull right up in there. I've got my board that I initially lined all these ribs up so that I knew that my hinges would fit. So I can line these center ribs up where they need to go. About right in there. My hinges will go down on this end. About so. So my hinges are going to bolt through these bottom two slats. My top toe board will bolt through this top three. Then I have 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to skip one, put a bolt here, skip one, put a bolt, skip one, put a bolt. So I'll have 3 bolts through the center, and then I'm going to take a nail, like is common on the rest of this, and I'll nail the other 3 in. I guess they'd be 4. 1, 2, 3, 4. So a little bit of a challenge to put this together, but the finished result is going to be much nicer than just the straight slats. Finish bolting it in, and I'm going to trim off my edges. Those will be flush on both sides. I think this will make a pretty acceptable driver's footboard for this front boot. Appreciate you following along. Thanks for watching.